So since we don't have small group this week, in this video, I'm going to go over the problems that we normally would have discussed in small group. So this one asks us, what are the domain and range of g of x equals negative 1/4 x minus 17 squared plus 61? So a good place to start is to graph this equation on your calculator. And then remember, to figure out domain and range, we're going to draw those boundaries around our function. So we're going to figure out the leftmost value, but there is no leftmost value, right? You see this parabola goes on forever. And there's no rightmost boundary either, because this parabola just keeps continuing forever. Okay, so the domain is going to be all real numbers. So let's look at those answer choices that match that. So that's F, G won't work, H, and then J won't work. So now let's think about the range. Remember, the range is all y values. So if we try to find the lowest value in y, well, this graph goes on forever in the lower direction, so there is no lowest value for y. There is a highest value because this graph comes up to y equals 61, and it doesn't go above that. So we know that it's going to be y less than or equal to 61. Remember, y is the same thing as g of x, which is the function. So this is g of x is less than or equal to 61. So that's how we get answer choice F. This one asks us, what's the range of negative x squared minus 2x plus 3? So range, remember, is y values. So we're going to go ahead and eliminate any choices that talk about x. So we're going to think about the lowest value of y. Well, if we look at this graph, once again, it goes on forever. So it's not going to have a lower y value. But it is going to have an upper value because you can see here the highest point in y is y equals 4. So this is going to be all y that's less than or equal to 4, which is how you get answer choice C. So here it says the quadratic function f is shown on the grid, which represents the domain of f. So domain, remember, is all x values. And these arrows show us that this parabola goes on forever. So it goes forever to the right and goes forever to the left. So we have no boundaries to draw. So that's going to be all real numbers. This one asks us, what's the domain of 9 minus x squared? So domain is x values. And when we graph this equation, we can see that it goes on forever in left for x and goes on forever to the right for x. So the domain is going to be all real numbers. So this asks us, which represents a function with a range of all real numbers greater than or equal to negative 6. Remember, range is y values. So we want y that's greater than or equal to negative 6. So if we look at this equation, the lowest value, or this graph, the lowest value on A is 0. So this is y greater than or equal to 0. So that's not the correct answer choice. If you look at C, it does, the lowest point is negative 6, and all the values are bigger than that. So C looks like a good choice. If we look at B, it does start off at negative 6, but then it goes below negative 6. So it's going to be y less than or equal to negative 6. So that's not the correct choice. And then D starts off at 0 and goes below 0. So this is going to be y less than or equal to 0. So that's what makes C the correct answer. So this asks us to write an equation based on this function shown on the grid. So what you do is you always start off with the vertex. So the vertex is at 0, 8. And a great place to start off is in vertex form, where you have y equals a times x minus h squared plus k. And remember, the coordinates of the vertex will be h and k. So I'm going to go ahead and plug that in. So I get y equals a times x minus 0 squared plus 8. So that's y equals ax squared plus 8. So now all we need to do is pick another point on the graph. I'm going to pick this one because it's an x-intercept. So that point is 4, 0. Remember, this was the point 0, 8. So I'm going to go ahead and plug that in for x and y in my equation. So when I do that, I get 0 equals a times 4 squared plus 8. So I get 0 equals 16a plus 8. So now I need to solve this equation for a. So I subtract 8 from both sides, and that gives me negative 8 equals 16a. Now if I divide both sides by 16, I can solve for the value of a. So that gives me negative 1/2 equals a. So remember, this was the form of the equation I wrote. So now if I plug in negative 1/2 for a, I get y equals negative 1/2 x squared plus 8, which matches answer choice H. So this, once again, asks us to write a function for this graph. So I'm going to start off with a vertex. So the vertex of this is at 3, negative 9. So I'm going to start off with vertex form, y equals a times x minus h squared plus k. So you have y equals a times x minus 3 squared plus negative 9. So this gives me y equals a times x minus 3 squared minus 9. So now you just pick another point that's on your graph. I'm going to pick this one right here because it's 0, 0. And I'm going to plug that in for x and y in my equation. So I get 0 equals a times 0 minus 3 squared minus 9. So I get 0 equals a times negative 3 squared minus 9. Remember, even if you square a negative number, whenever you square something, the answer is always positive. So this is going to be 9a minus 9. So then I add 9 to both sides, and I get 9 equals 9a. Then you divide both sides by 9, and you get 1 equals a. So when I plug that into this equation right here, I get y equals 1 times x minus 3 squared minus 9. Well, I have a little bit of extra work because if I look here, all my answers are in standard form. So I need to convert this from vertex form to standard form. So what I'm going to do is I'm going to expand out that x minus 3 squared. So x minus 3 squared, remember, is x minus 3 times x minus 3. So that's going to be x times x minus 3 minus 3 times x minus 3. So that's going to give me x squared minus 3x plus 9, which gives me x squared minus 6x plus 9. So when I go back to my equation, I get y equals x squared minus 6x plus 9 minus 9. I just plug this back in right here. And then I get y equals x squared minus 6x, and these two will cancel each other out, so I have x squared minus 6x. So that's going to give me answer choice H. So here it gives me an equation. It shows it gives me a graph. It says that shows the height of the feet of an object above a ground t seconds after it was launched. So which equation represents the graph? So what we do is we start off with a vertex. So the vertex is at 264. So that's my h and k values. So I go to y equals a times x minus 2 squared plus 64. So now I pick a point for x and y. So this 0, 0 is a really good point to pick. So I'm going to pick that and plug that in. So I get 0 equals a times 0 minus 2 squared plus 64. So I get 0 equals a times negative 2 squared plus 64. 0 equals 4a plus 64. So now I need to solve for a, so I subtract 64 from both sides. And then I have negative 64 equals 4a. So now I need to divide both sides by 4, and that gives me a equals negative 64 divided by 4, which is negative 16. So now I'm going to go back to this equation and plug in that negative 16. So I get y equals negative 16 times x minus 2 squared plus 64. So I need to expand out this x minus 2 squared. So that's x minus 2 times x minus 2, which is going to be x times x minus 2 times x minus 2. So that's going to be x squared minus 2x plus 4. So you get x squared minus 4x plus 4. So let's go back to this equation and plug that in. So you get y equals negative 16 times x squared minus 4x plus 4 plus 64. So you get y equals negative 16x squared plus 16 times 4, which is 64, so plus 64x minus 64 plus 64. So these last two terms are going to cancel, and you get y equals negative 16x squared plus 64x. So here, instead of x, they have t, because remember the x value was time, so that's why C is the correct answer choice. So this asks you, what is the maximum value of the graph? So the maximum value is the max of h of t, which, remember, the function is the y value. So we're going to go here to the maximum, which is right here at the vertex, and you can read that from your graph. So the maximum is at 225, so 225 is the max value of this function. So this question is a transformation question. It tells you that f of x equals x squared is transformed to h of x equals 2 times f of x. So when we look at this, when we have h of x equals 2 times f of x, we have that number on the outside. So we know it's going to be a vertical change. Since it's being multiplied to f of x, remember this is an a times f of x change. So it's going to be a stretch or a compression. So since a is bigger than 1, this is going to be a stretch. So remember, the graph is going to look narrower because it's going to be stretched vertically. So f doesn't work because in this one the graph is just shifted upwards. H doesn't work because in this one the graph is shifted right. G doesn't work because look here, the transformed graph is actually wider than the original, so that is going to be a vertical compression. So that's the opposite of what we're looking for. J is the correct answer because you can see here, compared to the original, this transformed graph is narrower, so that's going to be vertically stretched. So here we have the graph f of x equals x squared shown on the grid. So what statement about the relationship between the graph of f and the graph of g of x equals 7x squared is true? So g of x equals 7x squared, so we have that a times f of x situation where a is bigger than 1. So our graph that we want is going to be narrower than the original graph, and that's what I've sketched here. Because the original graph was drawn in bold right here, so the new graph is going to be vertically stretched, so it's going to be narrower. So that's how we get answer choice F. So it says quadratic functions q and w are graphed on the same coordinate grid. The vertex of q is 18 below the vertex of the graph of w. Which pair of functions could have been used to create the graphs of q and w? So we want q to be 18 units below w. So remember, the way we do that is we're going to say q of x equals w of x minus 18. Because remember, when we're shifting downwards, we have that minus 18 on the end. So we want this. So look at these. In all our answer choices, it tells us that w of x is x squared. So if we plug that in, we get q of x equals x squared minus 18. And so that's why D is the correct answer choice. So in this one, it tells us that a projectile is launched into the air from the ground, and it gives us a table with the height at different times. So we want a function to best model the situation. So we're going to need to do this as a quadratic regression on our calculator. Remember, since this is the independent variable, it'll be L1. And since this is the dependent variable, it's going to be entered into L2. So you start off by turning on your calculator and you click Stat. And then you hit Enter on 1, which is edit. Then in L1, you're going to enter these values one at a time. So you're going to enter 5, 10, 15, 20, 25, 30, and 35. Then what you're going to do is you're going to arrow over to L2, and you're going to enter all the second column into L2. So you're going to enter 1353, 2460, 3323, 3940, 4313, 4440, and 4323. Then what you're going to do is you're going to click Stat once again, and then you're going to arrow to the right, and you're going to choose Calculate. Then from calculate, you're going to arrow down, or you're going to click option 5, which is quadratic regression. And then hit enter. Then it'll give you the values of a, b, and c, and it does show you your function is y equals ax squared plus bx plus c, right? It tells you that on the calculator. In this case, y is h of t, so this is going to be h of t equals, and then our x in this case is time. So we're going to round these numbers that it gives to us. So we have negative 4.9 t squared plus 295t plus that 0.57, they round it to 0.6. So that's how we get answer choice B. So the A values, remember, were negative 4.899. B was 294.962. And then C was 0.5714. And so when we round that, we get this equation.